All right, we're set. So if you're remote, make sure that you unmute. Yeah. Okay. Good. Somewhere here. Okay, so I'll restart here so that we can connect with the lab. Okay. Okay, so these are just a few slides so that we keep them in mind while we do the lab about using D3 for creating maps. And so obviously the first thing that you need to do is to be able to load these files that allow you to show the geometries that you want to put on the map. And those can be different things. They can be the part of the map itself. So you can have a layer with boundaries, say a coropace of the United States, or they can be place markers or other geometries that relate to, say, the topography or other information that is spatial in nature. So they all would go into this GeoJSON format. And the way you use it in D3 is obviously the same way that you would just load any JSON file. So here we have this US JSON that happen to be boundaries for the continental United States. And we load it with D3.json with the promise. This here is step one. These files, we saw that they can be either in geographical coordinates, meaning latitude and longitude, or they can be projected. If they're projected, they're in pixel coordinates, basically, right? And then you can use them as they are. In this particular case here, this US JSON, we can open it and just look at the coordinates, and we'll see that they contain latitude, longitude. Okay. So in order for us to use it, we need to do the second part of the geographical mapping pipeline that which we saw on Monday. That consists in taking these features from the GeoJSON files and projecting them with a projection that is appropriate. Because this is for the United States, we want the islands, we want Alaska to appear alongside the mainland. What we do is that we use the Albert, that is projection that you remember is conic and conformal. But this particular one, the USA, is the one that has different projection for each one of the areas that consist of Alaska, mainland, and then the island, so that you can see them all at once. So this is already set up by D3, so you don't have to worry about the math. Basically, the only thing that you need to say is what is the size in which you want to have the map realized, right? And then the projection is going to give you the projected coordinates for the features that are in this GeoJSON that you want to turn into path that then you can data join with, right? And so the data join is down here, you see it, and it's quite simple. We do this, the features you might remember, it's an array. So what we do here is that we get these GeoJSON features that at this point are not projected yet, but what we want to do is do a data join for each one of the features that are in the array. So similar to what we would do for a data point to an array of data. Because they're not there, we're going to add them. And for each one, we're going to create a pass. And the pass is where the projection happens. So this is so the pass here is a function that is also provided by D3 through this GeoPass. That is a pass generator. So this is similar to what we did with the line generator, right? Where the line you need to link your data points to have a pass for the actual line. Here, what you need to do is to link the geographical coordinates for a given feature into a pass. And as you do this, you want to project it. Yeah. So it's exactly the same thing as the line, but this time the line we would do the math down here, but here what you do it is that you first take this path generator that generates a path from the features, and then this path gets projected based on the projection that we want. So it ends up being a pixel coordinates that we can just put in the paper. Yeah. So it looks complicated, but really it's just these two extra steps here, and it's a normal data join. With TopoJSON, it's a little bit different in that D3. So TopoJSON is Mike Bostock who created this thing. So it now became a little bit of a standard. So not all software understands TopoJSON, especially when it comes to rendering it. And so D3 is not an exception to that. So your TopoJSON, you need to turn it back into GeoJSON, and then you can use it. So D3 doesn't do that, but there is this TopoJSON library that also comes from the same author of D3 that does this work. Right? So it takes the TopoJSON features and converts them to GeoJSON. And then it's basically the same process that you need to go through to put it on screen. And in this case, it's simplified because you see that there is nothing that has to do with the projection, because these features are already projected in the TopoJSON, which saves you a step, right? So that otherwise you would need to implement in the page, and if you have a lot of features, then it takes time. So this you would do it as an optimization. So in the lab, we're going to see how to do the steps. Hold on. This particular one, we're going also to see in the code here that this last step here that here I think it's plotting the states, but then we don't want to put the boundaries around it, and we don't want to repeat the interior boundaries. And so there is this rule here that you need to implement in order to do that, but we're going to see this during the lab. A few more considerations. So maps are basically layered displays of information. So you might have your base map, and then you have thematic layers that have to do with different things that you want to show on the map. And so oftentimes you end up loading the base layer and then your thematic layers, right? So if you want to do proportional symbol map, then you'll have some counts that are going to be for a set of locations on the map. So you need to load the GeoJSON for your base map, and then for doing the bubbles, you'll need also to load your data, right? So you can put the bubbles on top. So that's one way to do it. And if you do that, then you end up having multiple data files that you need to load. And we saw that the promises, they're kind of working one at a time. So you can, there are different ways to do that. You can use the async await mechanism that is basically similar to the .then mechanism, but I think the easiest for you is to use the nesting. So you nest one promise inside another, and then in the second one you're going to put your code. But you can also do the same with promise all. So this is now standard in JavaScript. You basically say, okay, these are my 5 or 6 promises that I need to run. Just let me know when they're all resolved. And then you get an array of results for all the promises. Okay, so, and I think I can show you some examples of this if you need, mostly for the project, but it's quite simple to implement. D3 had something that was working similar in case you run into it, that is this D3Q. So they did it before the promise mechanism was implemented. So if you see code with this, you probably don't want to use it. Yeah, and I think I discussed already the different ways of optimizing for getting the pages in to load faster by projecting already the data in your files. Okay, so moving on with the lab. So this one is going to be a lot of practice, and there are quite a bit of tools that are that people use. So we're not going to see all the tools, but this is a list of maybe a subset of what you may want to use to deal with maps. So the map box, if you haven't done so already, try to go and get to sign up with Mapbox, and you need to get an access token so you can do the exercises in the lab. Curl is yeah. If you want to install it, it's fine. Otherwise, I think I remove this from the lab. But this is another way to, instead of using the browser to go get your data from an API, you can just do it from the command line. So if you have a lot of data to download at once, that is practical to do so. These two are basically editors and viewers online for GeoJSON. I don't remember if you need to create an account with one of them. But yeah, that we can do during the lab. This Gedal and Augur are related here, and so these are kind of open source libraries to deal with vector geospatial data. So that's useful for transforming between different file formats. So I would say for today, at least go create an account with the Mapbox so we can go and play around with these things. I think this is up to date, maybe not. I think there are 10 only. But I'll move on to that one. Now, oh, this is it. That's right. Yeah, there are 11. Okay, good. All right. Just give me a second. I'm setting up the desktop so that we can go through this in an easier fashion. Okay. Here we are. Okay. Yeah. So this is the lab, and the assignment is down here. So yeah, maybe after the break we'll look at the assignment. So you can see that in the lab we have the package.json, so that is independent of the one that is outside. So this one you'll want to use for the assignment, and we're going to go ahead and use the one that is in the lab, which I think I already set up in this way. npm install, yes, so we're at the right place. Yeah, here it is. Okay, so there are 11. We changed a little bit the numbering with the lab slide, but it's basically a one-to-one. There are 11. Okay. Okay, the first one is this is very simple stuff. It's just to get familiar with this latitude, longitude, and you go and find the local information on maps. So for this, you just do what is asked there to do a USC lat long in Google, and then you'll want to open up the file. Google Maps. Oh, this is just Google. Sorry. Okay, here it is. So you have it there, right? So these are the geographical coordinates, right? And so what is asked there is that you just go and paste them in here. Geographical coordinates. Okay. So this is it. Right? So now you see that this is in degrees, right? And let's go and let's see what happens if we go in Google Maps and zoom in USC. Okay, so here we are. Okay, so if you do, I think, right click and do what's here. So you see here that already the numbers are different, right? There is a sign. And so this is what you want, and you see the sign is also in here, okay? So in the GeoJSON files, what you want to use is the signed version, right? We don't want to use the one that has the Eastern and Northern, right? So that's kind of importance. So this you want to go and basically put it in here. Okay. Okay, so there I put my answer. Right, so 28. Okay, so it's a bit of a pain to copy, but all right. So then you may want to explain what, I mean, there is nothing to explain here, but which one is the latitude, which one is the longitude. I'll let you sort this out. But this is the standard. Oops, sorry. Okay, so let's go back to this page. Okay. So here we have the what's here. Okay. So then we're going. So here we understand basically. So yeah. From the first two, obviously you're going to find out that this is the latitude, right? Because it's going north, and this is the longitude, right? So you want probably to put this in the answer while you're at that, and the point to remember here is that you want to use the decimal notation without the degrees and northing and easting or western direction here. For the third point is about the projection. So if we go here, this is basically Google Maps completely zoomed out, right? And the question here is, what projection is this? And what are its properties? So can somebody give me a quick answer? So is it a sleepy map? Is it a static map? Is it a thematic map? Is sleepy sounds good. Okay. So I'm going to put the check here, but obviously this is a checkbox. So when I leave the page, it's gone. So for the homework, you want to go and put a checked in front of it. So here we have math format. Here, sleepy map. Right, so this is the checkbox. If you put checked, it's going to set it. Okay. I suggest you do it so that it's done already. Okay, so why sleepy map? Because you see that you can move around the map, this map by just dragging, right? And that's why the people give it this name. Is it a thematic map? So a thematic map is it's a map with a theme, right? Not necessarily a named map. So I would say that yes, because here the theme is to display the countries and the states, right? So there is a theme to this map. We have boundaries here for the countries and their names. So I would say that it's a thematic map. Where is it? Yeah. Okay. Is it vector or raster? Vector. Why? How can you tell? What's the difference between the raster and the vector? Simple. The raster is just a picture, right? So you see the tiles here that appear when now I zoomed out, so I need to. Yeah, you saw the tiles there. That was one tile. So the question is the tile a picture or is it vector data, SVG, right? So in my opinion, it's if you just look at a static picture of the map, then it's hard to tell. If you start interacting with it, you see that the labels, they appear, they disappear, right? So this is not a picture. Because you have some geometries that are appearing depending on the zoom level. And the player here that is rendering this map decides based on the zoom level what should be shown and what shouldn't be shown. Right. And this is all information that is in SVG form with different layers. Probably there is a layer for the names, there is a layer for the road network, there is a layer for the base map here where you see the ground with shading and the body of water and so on. Yeah. Now, if I go to the satellite view, you see that this is a mix, right? Now the background is a picture, and you can see it because when you zoom, you see when you zoom in, things get blurry because it's loading the picture dynamically, and you don't get right away you get a coarse resolution first of the picture, and then you get the rest. But you still have, you see the road network that is on top and the names. So those are additional layers, right? So here we have tiles that are raster and vector together, but the default is to just have vector tiles. And again, it's multiple layers of vector data. You don't just get everything at once in one layer. Okay, good. Okay, so projection. What projection do we have here? Louder. Mercator. Yeah. Yeah, I don't know how to spell it correctly. But it's the Mercator. Yeah. It's one of the Mercator projection that are part of the web Mercator type of projection. This one is on Google Maps, so it's probably the Google Web Mercator projection. Yeah, we would need to go and look into the docs for Google Maps to see exactly what they're using, but all these sleepy maps are using the web Mercator projection because you want it to be able to let people recognize places at large scale and also recognize features at a smaller scale. Now, at a smaller scale, you get pretty close to a plane. So there, you're pretty close to have something that is both conformal and equal area. Okay, but you need to go at smaller scale in order to do that because you can approximate the surface with a plane. So that's right. So what projection type? So this is you need to look it up in the slides. So it's cylindrical, right? Yeah, and here there is the conformal that is missing. Oh, oh no, this is correct. Yeah, but there is an extra box there that I don't know why. We should remove that. Projection properties preserved. So we say it's conformal. And that's about it, because you can't have two things at once, right? Okay. All right. So now that we understand a little bit these things, let's move on to something a little bit more complicated. And let's look at how you would do maps with pictures and or SVG. And here it's also about asking, answering questions. So if you open it up, again, it's important that you can use the dev tools to go and look at these things, to answer the questions, because you probably don't need to go and look up the code. What gets rendered should give you a hint about what it is. So map type for this one. I think we can click thematic if we want, right? Is it a sleepy map? No, you see it's just a picture, right? So it's a static map. Is it a vector? Okay, it doesn't. It's shown as you see here. If I drag it as a picture, so it's probably a raster, or at least it's how it's viewed displayed by the browser, right? To really know, we need to go and look at the code. But let's say that the determination here is based on what is visible from the browser. So here you see I'm actually using D3. This is the example 2, yeah, correct? No, 1. We're looking at 1. Example 1. So example 1, you see, is just a picture. So we can go and look at this with the dev tools. You see, it's an image. It's an image element. Now the image happens to be an SVG, but as soon as you put it on screen using the image tag, then what you end up having is just a picture. So in the sense that they're just a bunch of pixels, right? So it's definitely a raster. All right. So the projection for this one, what is it? You need to go look at the slides. I think I have 3 or 4 that you need to know. So this is the one for the United States, right? That is multiple projections into one space. Oops, sorry. I'm going to move up here. Somewhere in the middle. Here it is. That's the one, right? That's the Albers-Koenig. And that's the one that we saw today at the end. That was used. This one is projected. That is used here. It's the same, right? That's the GeoAlbers USA. Or at least that's the function that D3 uses to for the Albers projection. So what is it? Okay, so here we should have, it's the conic Albers, right? It's definitely not the Mercator, that's for sure. And the LCC, it could have been the LCC, but because here it's by, it's a composite projection, then it's probably not the LCC. Yeah, so the UTM, you remember what the UTM is? So the UTM is the one that is local, that uses metric coordinates, that has a Cartesian coordinate system. Yeah. So the data are in meters, eastern, northing. Okay, projection type, it's conic, obviously. And this one is the equal area, right? Okay, so we can go on with the second one. So the second one, you see that if I click and drag, nothing happens here. This is also an image, but with the image tag, right? So you can put images in SVG, inside the SVG, but they're not called, the tag is different from the IMG tag that you would use in HTML, is the image tag, okay? And then the parameters are working the same, and you pass a reference to the URL. Right? And here it's href instead of being source SRC, right? But the result is the same, is that you get a picture. So this is basically the same thing as the previous one. So moving on to the third one. So here you see I'm using something a little bit different. I'm using the D3 XML and this DOM string. So you want to go and read these before you go and answer the questions in the page. But let's go and look at this. You see that these are paths. Yeah. So this is definitely a vector, right? Yeah. You don't see the maps for second and third. You don't see the maps? Really? Yeah. And this. Yeah. No. Okay. I can take a look maybe at the break. But this is up to date. I know for a fact because I checked it before I opened it. Yeah. Are you using Chrome? Okay. So we look at the. We look at that, or maybe you don't have the. Do you have an error? Maybe you don't have the picture. The picture is there? No error. Okay. So I'll take a look at the break. You have to trust me for the moment. Okay. So this one is vector, right? Because you see that it's created by different paths. So now the path can be a closed polygon like here, right? So no, not necessarily just one line. And you see that yeah, every is these seem to be together here. So they might be, no, they're not grouped because they're different paths. Okay, it's just that they're appearing with the same ID. So these are made up together. They're built together. So all these islands, they seem to have Puerto Rico 1, and here we have Puerto Rico 2. No, it is just another name. It is another island that is, we don't know where. Anyhow, the other thing that is interesting that you see here is that the pass, they have an ID, right, with the state name. And the short for the name. So here we have California and .ca. Okay. So let's go and see how this is done. Okay, so you see that it's materialized here, obviously with the different paths. So here what we see is that basically we have an SVG that is embedded in the page as opposed to loaded as a picture, right? Yeah, and it starts here, and it's all inside a big group that is called US. Yeah. So now if we go and look in the code, which one is it? I think, is it this one? Yeah, here it is. So the difference now is that we're loading it with D3 and we're loading it as XML. So why are we doing this? If you just go through the logging, what is us there, you realize it. But basically, the idea here is that if you load the SVG as a picture, then it's going to be turned into pixels. And what you want really to do it is to load the content of the SVG and then create a DOM tree for it. Right? And the DOM tree is what we see in the page here, right? This is the DOM tree that corresponds to what the SVG file is, right? And so in order to do this, what we want is just load the file with these tags and the same hierarchy. And because SVG is a dialect of XML, we can just use XML to do that. So D3 XML is just going to load this into a hierarchy. And then what we do is that we just assign it to a node in the DOM tree by getting this hierarchy that gets loaded into an object that represents the hierarchy of nodes that you want to create in the DOM. Yeah, so that's a little bit the way it works. So if you go and read the docs for this function, you'll see that they just do that. Right? So now this is one way if you want to prototype a map and you have the SVG, right? And it's a static map or even dynamic. If you want to make it dynamic, then this is a good way to load it. You don't need to worry about doing projections or anything because it's already ready to go, right? The only thing that you might want to do is add the interaction just on top of it, but it's just basically working with SVG, right? And you don't, you just use the D3 here to load the SVG, but you don't do any data join because all you're doing is taking the SVG and creating a node for it that renders it. Yeah, so here you can play around with some of the functionality here where you can obviously, because now that you have it in the DOM, you can use D3 to do selection of some of the paths, and you can customize them based on your needs. All right, so number 2. Okay, Mapbox. So for this, you need to get the account with Mapbox. And then you need to follow the tutorial here on how to display a page. And they also tell you that you need to get the success token. And then you have the code that is already ready for you to go and play with. I don't know. So the access code is here, you see. I don't know if you can go and use this one, because I think that these are tied to URL. You might give it a shot, but I suggest that you also go and get, if it works, go and get the token for yourself so that you can use it for the project. Because here this one might only work. I mean, we can give it a try. Okay. Okay, so I made this simple for you, so you don't need to get too crazy, and we can get it done quickly. So I've set up this container here because you see that here it's rendered into their page, and I think they're using an iframe, so they're setting it up full screen for the iframe, and then they render it in the page. So this code is basically for a full screen map, and here we don't want it in that way. So all the first part here that is loading the map box, etc., I've already put it in, including the CSS and the styling for the container, so it should appear as we want it. So the only thing that you see the map is here. The only thing that you need to do is put the code to realize the map. That is everything that is in the script here. Okay, and this should work. Yeah, it is that simple. All right. Yeah. So, but please do change this thing. So, okay. So you see that basically this is a component, right? A component is something that you can use or reuse in web pages, and this one is just to render maps, right? And the library here provides you with this component, so it's very simple to use it. You just need to attach it to some ID and configure it. What configurations are needed here? They're essentially done in this options object here. So there is the container. You need to tell this component what is the HTML element or node where it needs to attach to, right? And so here we're using the ID of this map. Obviously, that needs to be unique because you can only attach one instance to one element. If you want multiple maps, you would need to create different IDs. The second one here is setting the style. So you see how things look here. They look a little bit, they're styled in a certain way, right? So all these map players, including Google, this one, Leaflet, etc., they also have tile servers, and so they allow you to use different aesthetics for the maps. So for the one that we're using here is defined by this streets v11. So if we want to make it dark, we can use dark v10, and then we get the dark theme that is there. Yeah. The center has to do with where you want the player to be centered, and the zoom level. What is the zoom level at which you're asking the tile server to provide you with the tile? Okay. So this information is essentially for the tile server to give you the pieces of map that you want to display. So this you need to look in the docs. They have these numbers. Everybody has different numbers. So if we go 15 here, where we zoomed in at the max, and if we go to 5, we're going to see the whole United Kingdom, maybe. Oh no, we're in Philly. Okay, we see the East Coast. Obviously, 1 is going to be. You might see the whole United States. Yes. Yeah. Right. So it is not more complicated than that. So once you have these maps in there, you already have a base layer. So the only thing that you need to do really is customize it and bring in the data and other things that you may want to add to the map. So here I'm asking that you do a little bit of customization by moving this map to the center where UAC is located, and we got already coordinates from this example, right? And again, the center here is these are in they tell you in longitude, latitude, right? So you just need to plug in the numbers for UAC, and you're good to go. You should see a map for UAC. The dark mode, you can go and see in here the specifications. So this is the string that we saw before. You define it, at least for Mapbox. Everybody has his own specification for these things. But this is how you do it in Mapbox, where you say Mapbox semicolon styles, and then you if it's there, you want to put your Mapbox username if you want, and then you put the style ID. And I think I gave you here the link for the dark mode. So they have pages that shows you pre-rendered what these maps are, how these maps look like. And so if you want to go and see it, you click here, and you see that here the name of that particular style appeared. So the V10 is because they have different versions. So sometimes they fix things, so they issue a new version of the map. So this one is supposed to be the latest one, because we're accessing it from the link that Mapbox provides. For the streets, you saw that it was different. I don't know if we can get to there. It's V11. Probably no. I think you know. You need to go through the page for the styles and do the same to access the others. So the street V11, I think, is the default. Yeah. All right. Yeah, and then to add a pin is as simple as basically going in the examples. So the examples are a good place to go look when you want to add something, because you can add all sorts of layers, and so for each type you have an example that comes with it. So this one is for the pins that they call markers. And if you go towards the bottom, I think there was one that no, yeah, this they don't have a tooltip. We'll do one with leaflet for the tooltips. So yeah, the marker you see is done here. You basically create a a marker with the Mapbox player, and you configure it by setting the longitude, latitude, and then you say, I want just to add it to my map, right? So it's not more complicated than that. Obviously, if you can also bring in GeoJSON data on top of this, if you have, and you will find an example that does that as well. Okay, so this is just to get you started with Mapbox. Example 3. This is basically the same with Leaflet. It's not more complicated. I think for the interest of time, I'd rather pass on it. But yeah, I'll comment a little bit on the code. So so here I put some pointers. So this is from the quick start. I put it there so you don't have to go and copy this. But the only thing that you want to add here is, again, the script part that configures and sets up the map using the leaflet component. And this is also set up so that it's going to appear in the page at the right size. Okay. But I think it's better that you do it on your own so you understand how these things work. The customization are basically the same. I think that here the difference is that I'm asking that you do a marker with a tooltip. And there in the example, you'll see that they have the example for, I think it's somewhere here, center at the pin. Here it is. I think I put the help somewhere. Where is it? No, this is 1, 2. Customize change box. Okay, add the pin here. Okay, let's go look it up. Yeah, this is just in here in the example. And if you go at the bottom, I think it's somewhere in there. It shows. So here they just add a pin, and then that is done here, pretty much in the same way that you would do with Mapbox, right? You create a marker and you configure it and you add to the map. And obviously there is an extra step to configure the bindings for the pop-up that you have there. The whole code is here. You just copy and paste this, and it should work. Yeah. Now, usually it's yeah. You'll see that here I'm using another ID, right, for the map, but the rest of the code that has to do with loading the component and styling, I don't need to repeat it. Right? I just set it up once. The only thing that I want to repeat is the container with a unique ID, because there are two different maps. So this code is just repeated here. Okay. So in this second one, obviously you need to use map2 to configure it, and that is also the case for the Mapbox example that we saw earlier. Where is the? Oh yeah, okay. Maybe I can show you here, but obviously in here you have the example. Here it is. Zoom layer. No, this is adding a layer. Oh, here. So here, this is where you set up the ID. Uh, yeah, another word of caution. Sometimes you think that it's a good idea to make this work with D3, because right, D3 you can do SVG on top of the map, but the maps are quite a bit different than just, as you saw, that just manipulating SVG. So usually it's more complicated than you think when you want to use D3 with one of these. So you'll find some examples online, but usually the better idea is to see if there is some native way to support the functionality that you want to add without pulling in D3. Okay. So maybe we do a quick break, and then I'll go on with the 4. You want to show me? What's going on with the example 2? Okay, I'll restart with a few loose ends here. So some people were not seeing the maps in exercise 2. That is these maps. Yeah, the second one and the third one. So if you have that, make sure that you are running the npm install inside the lab. Because otherwise you're using the package.json that is outside here, and that, as you can see, is much less than what is here. So you're not going to be able to do the to display some of the things. Yeah, so if you also do the npm install in here, you should not get too many errors. Let me redo it so that we see what I have. Modules. Okay, the topo.json errors there. It's because I'm using an older version, so for the moment we can ignore it. These, I think that they all have to do with the highlight.js that I'm using down here. That is not maintained anymore, and that is just to highlight the code, so you can also ignore it. But you should not get more than that. If you do, you probably want to upgrade your node installation, and what I have is version 8. That is the latest stable. Okay, hope that helps. All right, so I'll get back. I think we were already dealing with the number 4. I'll go back there. Okay, so we don't need this. I don't understand why I don't have to. Okay. I'm just looking for the close button that I don't see anymore in the DevTools, but that's fine. All right. So here we're going to play a little bit with GeoJSON. So usually it's complicated to do things with GeoJSON files because they're usually big. So here is an example where things are manageable. So you get used to it and you know to edit it in different ways. So the example is about using features that have to do with building footprints. We're going to work essentially on the USC campus, and the city of LA as a data portal where they are sharing some of this footprint for the city of LA. That include the USC campus. So as you can see here in the picture, where I have I went in the city portal and selected this building here. That is the EDCO building. So I'm going to show you how you do this. Okay. So they changed it because this looked different last year. So yesterday I made sure that I understand now what is what. But the default view now is a table. Here you have this tab here that basically shows you information on the data. If you click on the view data table, you end up at the same location, obviously. Then you have a button here to filter the data and to download. Now in the filter, you see that you can filter by the properties here that are listed in the as columns for the table. So we're going to use that to filter by building ID. And you need to be careful with this one. No, this is not important. Then in the download, this is the toggle that you want to pay attention to, because this applies the filter that you've defined in the filter data. So if you want to filter certain buildings by ID, you would do it in the filter data page, and then you would go to the download tab here and set this up so that whatever you download is going to be used using the filters. So in terms of data format here, you see that you get the CSV, and that basically gives you the data in the table, and it's not very interesting from the point of view of maps. The KML is the format that Google Maps uses. The shape files, we're going to see later on what this is. And the GeoJSON is what we're after, right? So let's go and look at the map. So for looking at the map, you need to go and click this button here, View Map. And you need to go and look for USC that is right here. Okay, so the blue things are the features for the footprints. Okay, so if I want to select as in the picture, I would go there. And if you click this one, then you see the properties that are the same that what you would see in the table. So I'm going to copy this one, this building ID. So you see that they have an object ID and the building ID. I think that both are unique. I would go with the building ID just because it looks more complicated. So there are less chances that there is a conflict, but I think they're both unique. And then you have some properties for the building that are listed here that you might want to use depending on your application. I think that I'm asking EX4 that you paste this somewhere. Okay, yeah, add the building ID here. Here, you see. Okay. Now to get the GeoJSON from the download, we need to go and filter. So we're going to filter by ID and paste this here. And you need to hit return, otherwise, did you do it? Okay. Okay, I hopefully it's there. Oh, okay, no, sorry. Okay, I'll redo it because this is confusing. So up, so you need to select building ID, then you paste the ID in there, and you need to move your mouse down and click on the number that is the same than above. I thought you had to return it to just type return, but you need to actually move your mouse under the entry box, and then click the number that appears, and you see that now it's selected. So once you do that, you can come here and do toggle filters, and it tells you that there is one record that is being filtered, and then you can go and click on the download. Okay, now this is magic because I did it yesterday and it was taking quite a bit of time. So my Visual Studio Code here is set up to open the JSON file, so that's why it appears here, but it's from the downloads. So what you want to do is just go and paste it there. The formatting is fine. Now you have another way of getting this data, that is to use an API. So usually that's the preferred way to use the APIs than to just do the manual download, so you can automate your process of chart creations. And for this, you need to go back to the info, and I want to use this. Okay, I think I put it in the instructions, but you want to click here. I want to use this, and then here you have the View API resources. And then you need to click on Open in API Explorer. At least that's how I understand it works. So here you need to refilter again, because if you copy this to the so the way it works is this is the URL for the API. So you can just paste it in the browser, and it's going to return the results. And the default is to return all the footprints that they have, which is a lot. So you don't want to do that. Instead, you want to filter it. And you want to filter here by building ID. And there you'll want to find the ID that you're interested in and put it in there. And this time you need to press return, and it gets added. Yeah, and then you can add more if you want. Maybe you saw, but you see that the ID should be listed in here 40. It's here, right? 47, 44, etc. is listed in there already. So we can just copy this and go in here and hit return, and then we get it back. Okay. So this is the response over the API. So I'm going to put it in the page so we can compare it. Okay. So if you use the command palette, you can and type wrap. You'll get the toggled word wrap, which allows you to see things in one screen. Yeah, I wanted to paste the query URL also. That is this one. All right. Now you see that the response that you get here is different from the GeoJSON. So the GeoJSON that you get from the downloads is a feature collection, right? So this is kind of the umbrella, and this feature collection has these features. And so the features are an array of objects that are of type feature, and then they can have IDs and properties, right? And the geometry. So the geometry for this particular one, we only have one object because we have one building, is of type polygon, right? Now, in the response here, we do get this information that is somewhere down here. So if you want to look at this in a better way, it's easier if you format it. So you can put it in a new page here, and you select everything and format the document. And Visual Studio Code is smart enough to see that this is JSON, so it's going to format it accordingly. So you see that here we have an object that is basically how we've configured the query, which we don't necessarily care about. This is information of where this footprint data is coming from, which we also don't care. And these are the features that we have seen that are the same that you get with the download, right? So if you get multiple, you probably will want to just go and get the features part and paste it into a feature collection, such as here, right? So multiple buildings would give you multiple objects in the yeah, it's up to here in the array of features, right? Now the reason you want to be familiar with this is that if anything goes wrong in your map, you want to trace it back first to the data to understand if you have the right data. Okay. So we're going to see a little bit what tools we can use for that. So I'm going to save this and go back to our page that is down here. And okay, so now we have the answers for the first question. So if you want to do multiple buildings, you basically do this, what I did with the service and or the filter and the download. But if you have a lot, then probably the API is the better way to do it. In which case you need to go back to the API that is posted. Is it here? It's here. Okay. Okay. And add other buildings here, right? Like so. And you don't want an end, you want an or with the building ID and just put the other building's ID there. You run your query and then you get it back and you paste it in the doc there so that you show that you know how to do it. So it's for here. So yeah, if you want to experiment with curl, because sometimes you know if you have to download hundreds of these, is not practical to do. So probably the better way to do it is to get all the IDs that you're interested in and create the query string, and then you just use curl to get the ID, the query response without going through the browser and saving it into a file. So it's as easy as saying my file has this name, and here you pass the query string that is the query URL that is what we pasted in the browser earlier. So I'm, you know, if you want to give it a shot to know how it works, you can do it, but I'm not asking that you do much with it. It's mostly for the project if you need it. Okay. So as I was saying, sometimes you need to know if the geometries are correct because things don't render correctly. So for this, you can use online tools to either edit or display, to fix problems or create new geometries. So one such tool is the geojson.io. So this one allows you to do some editing. I can show you how we can do that. Say you need a footprint for a building that is not there and you need to create it manually. Then this tool would allow you to do that. The second one, it just allows you to see it. Okay, so maybe I'll start through the second one. So let's say that we're not sure of if the geometry is rendering correctly, and we don't know if it's a bug with our D3 code or if it's a bug with the data. So what you do is that you go back to your feature, you copy it and you paste it in this location, then you see that it looks good, right? So there is no problem with the data. Here you cannot do any editing, I think, even if you, they have a login, but even if you log in, I don't think that you can edit anything. And for that, you want to turn to the second one here, that is the first, the GeoJSON IO. So I'm going to put this here. So it looks eerily similar with different colors. Probably because they're using the same map component for the UI. So we have it here. So, but supposing that is not there and we want to create a new one. So I'm going to remove it. Okay, it doesn't. Yeah. Don't ask me why it refuses to remove it. I think you need to select it and then delete it. Is that oh, okay? So here you see that you can go and fix things if you don't like them, right? So, but I'm going just to delete it. Click the feature to remove. Okay, now it's gone. Okay. Now we still see a footprint because this is the footprint that is coming with the map that is used here to render, right? And if you go in any of the maps today, Google Maps, etc., you saw that you already have the location for the buildings that is already in the map as a layer. So if I want to create, if I don't have a footprint for this this building that I want to use with D3, then what I would do is go and create a polygon maybe with this one, and you see that it does it. I don't know if it did it or it remembers the old one. Maybe, I don't know. But if you want to create something different, right, you can just use the tool and then you have it there. So we're going to okay, remove this one. Okay, and save it. Okay, so hopefully it loses its memory. So this is the footprint that we created. Okay, that then you can go and add as a feature. So you just take this part, right? That is the one of the array of features, and you can add it to your data, and you should be able to display it with different. Right. So once you have it here, we're not jumping to the free because it's a little bit different. We already use Mapbox. So here, what we're going to try to do is just to load it from the using Mapbox. And the way you load the geometry in GeoJSON in Mapbox is with this code. Basically, after you've created your map, you want to bind the map event. So this is the load event when the page is loaded. That is just the browser event, right? So similar to the events that we've been using with D3, except that here we're using it with Mapbox. And what we do when the page loads is to actually go and get this data in at this location. Now, again, this is working because we're using browser sync. So this creates a request to a URL that is the local host where we're running /data/footprint.json, and it will find it there if you place the footprints.json GeoJSON file in there, right? Once you've loaded, so this happens as soon as the page loads, then you can use it by adding a layer for it. And the code is just there, and you see that the layer is referenced based on the source. Yeah. Now, yeah. So this is binding only to the load event for the page, right? It's actually not doing anything until the page loads, right? But whenever you have whenever the data are loaded, then Mapbox keeps track of it by this ID here that you specify when you add the source, and then you can just use the ID to add it to the map. So that's basically what this code is doing. Yeah, so it's not very complicated. As soon as you do basically the example 2, you just copy and paste the code in here and add this under the Mapbox component creation, and things will show as you expect. Okay, so let me go to 5. So 5 is basically doing the same type of manipulation here with GeoJSON, but this time with difference. So it has a lot to do with what we've seen at the end for the last slides for the course, where you need to set up the projection in order to load the data. Use d3.json to load the GeoJSON and so on. So in this example, we're here I've already set up something for you, so you can just go and look at the code so that you understand a little bit how it works in terms of displaying the features from the GeoJSON, and understanding also how you can customize. So here, for instance, I've been selecting California and changing the color of the pass. For California, I'm putting a dot here on the city of LA. So we can go and look how this is done, and I think it's just really understanding the code in this example. And I put a little bit of comment, but for the things that you're not familiar with, you should go and look them up in the documentation, because here, for instance, we're doing a projection with GeoAlbers USA. If you need to use a different projection, the first thing to do is to go look up the docs to try to understand exactly what these are, because all you have to work with here are function names. So you want to make sure that you're using the right thing. So the center, I've explained it already, right? So this is moving the center for the map at this longitude and no, latitude and longitude. No, longitude and latitude, sorry. And then we set it up so that it's in the middle here of the area that we want to draw, and scale it. Now the scale factors here have nothing to do with the scaling that we saw in Mapbox, because there the scale is for the tiles, right? And is the zoom level. Here is the scale factor that you want to apply to the projection. So here I've come up with something that works for me. Depending on what projection you're using, this number might be completely different. So the second block of code here is basically doing the same thing in a different way. So instead of setting these numbers, because it's complicated to do, right? It's a trial and error. Then D3 projection as a fit size, where you basically just say, this is my width and height for my SVG. Just put them up in there, and it's going to automatically be centered, and you don't have to worry about it. Now, why am I doing this thing here? Just selecting the feature number 4. So this is for this picture. Can somebody tell me? Here, JSON feature number 4. So these are getting loaded here, right? Data us.json. So we can go and open up this thing. Data us.json. Here it is. And you see feature number 4 here. This is ID 4. So the fourth one is 1, 2, 3, 4. Oh, it is not 1. It will start at 0 again. So the fourth is this one, right? It's California. In the array. And so what I'm doing here is that I want to fit only the path for California into the SVG. Okay, so the way I do this is that, oops, was it 5? It's 5. 5 is I just select the feature for California, and I say fit this one, right? Yeah. So this is going to do the same thing as here. Here I did it the hard way, trying to move things as I wanted. And if you do this, you'll see probably the same, exact same location, but it's set up automatically. So the equivalent of setting up a marker is done here, right? So long lat here for the marker is, I think I'm reusing here the USC. And this is in geographical coordinates. So if we want to put it on the map, we need to project it. And we need to project it with the same projection that we're using for projecting the features, right? So this you do simply by saying projection, and you put the marker in. Now, because this is running in the page, yeah, I don't know. Yeah, we will need to. Maybe you can just go if you want to do it. Okay, can I get my? Okay. Here we go. Let me see if I can just go and put a breakpoint there. Okay, 5. There we go. Okay, we're going to reload this. Okay, so at this point, okay, so we're going to just step once. So we have the markers, so again, right? And now we can just run this. Okay, so these are the pixel coordinates for the projected point. Okay, 145.5 and 222.55. And so once we have this, then the only thing that we need to do is basically add it to the map, which is readily done. Oops, sorry. All right. Okay. So in this particular case here, we're not adding it, but it's added here to the second one, where the second example where we draw all the features inside this us.json. And we may want to go and look at how this is done. So you saw that before we went and got California. Where is it? Using the array notation, right, in the features. And obviously you can also query by ID. And I think that is what is done. Where is it? Where is it? Okay, fit size, this is the same thing. Yeah, is this one that does the graticule. So the graticule is what you see here, are these lines that are in the back that shows the parallel and the great circles for reference. So those are the equivalent of the grid lines that you would have in a Cartesian chart, right? Here. So this is where we're changing the color for the California. Here you see that we're going by ID. We're setting the field to this yellow color or white, depending if it's the ID is a 06 or not. And okay, so you see that the ID for California is 06, so we're just referencing this one. Yeah. All right. Okay. 6. Okay, 6, 7, 8, 9, etc. They're basically all the same thing. It's doing similar things with D3, but a little bit more complicated. As here we're using starting to use actual layouts. So in 6 we look at how to do projected GeoJSON so that you get a topo.json that you can just display, and it's this example. So it's time. So I'll just tell you about that, and maybe we can finish up on Monday if you have questions. Here is to basically play around with more data from the city of LA for LA County, and in different formats, and how to add data to those types of GeoJSON. In some instances, you will not find the GeoJSON for your map. And so here is an example of how you can source it from a shapefile, because most of these map data are produced as shapefiles, and then they get converted to GeoJSON. So this is basically going through that process. And I think that 9, 10, 11 are about, yeah, this is again projecting the GeoJSON into TopoJSON and so on with the tools. Yeah, so we need to finish this next week. The last two are just the layout for the proportional symbol map and the choropleth one with data. So here we're using features plus a layer of data. Right? So, okay, so we resume on Monday, and if need be, we can do maybe a few days of extension for this one. All right.